This is going on page 109. We are done. We're going to look at some basic polar equations. So these are kind of the boring ones. All right, we'll get into some cool ones, but we got to get through the boring stuff first. Remember that your polar coordinates are always r theta, right? Instead of x, y. So what we have, we looked at ordered pairs and stuff yesterday. We have a polar equation now that we can graph. It's an equation expressed in terms of r and theta instead of in x and y. But just like our equations that are expressed in x and y, we could have x like 2x plus 3 equals y that has x and y in it. Or we could just have y equals 3 or x equals 3. That works as well. So some examples here would be like r equals 3. Theta equals pi halves. R equals 2 cosine theta. Or r equals 3 sine theta minus 4. Something like that. Okay, those are just some examples of what could exist. So let's talk about, so the first two that I wrote down is just r equals something and theta equals something. So it's like in the rectangular coordinate plane where we were still using x and y. If I wanted to graph the line x equals 2, is that a vertical or horizontal line? It's vertical, because no matter what the y value is, the x value is always going to be 2, right? So this right here would be x equals 2. Then if y equals 3, it's going to be something like this, because no matter what the x value is, the y value is always 3. Right? Those are the easiest lines to graph, although they are probably the most missed because you can't keep track of what's x and what's y. Right? We good on that? Okay, so let's look at what happens when we try and graph the equation r equals 2. Right? So that means if theta is 0, r is 2. If theta is pi thirds, r is 2. If theta is 5 pi 6, r is 2. Theta is 7 pi 6, r is 2. 3 pi halves, r is 2. And so forth and so on. If I kept going and did every single angle, what would I graph? A circle. And we are not to the, it's a bad circle, but it's a circle. We are not to the converting part yet where we're going to convert them from rectangular to polar, but just FYI, because this is something that you did in geometry. If I was going to graph that exact circle in the rectangular coordinate plane, then my equation looks like this. X squared plus y squared equals 4. So that's what that would look like in the rectangular coordinate plane. It's a much simpler equation in the polar coordinate system. We good with that? Questions? All right, so if r is negative 4.5, then I would go, if theta is 0, I go to negative 4.5, and there's a point. If r is pi thirds, negative 4.5, and there's a point. Pi halves, negative 4.5. What am I going to graph? A circle again, because it's the exact same type of thing. All right, so you can put a few points in there just so I can, and even though my first one was really bad, this one's not necessarily bad. I usually do a dotted line because it makes it at least a little bit better. Mine don't look dotted anymore because it's bored, but. Okay, and here's a little side note. So don't graph and write what I'm about to do, but I just want to talk about it because this question came up a couple of times yesterday, and I don't remember what classes it came up in, and I don't think I talked to y'all about it as a class anyway. But let's say that we had this ordered pair, which you're not going to graph, but I am. That is negative 4 pi 6. Okay, so the actual mathematical rule is that you graph 4 comma pi plus pi 6. But I told you we can go to 4, we can go to pi 6, and basically adding that pi, it's like passing through the origin, and we go right here. Not that one. I think my knuckle did that. Sorry. So the question that came up, or some people said, well, what I was doing, and it works, is I go to -4, and then I go to pi 6. Okay, there is no -4. Look at I know on the thing I gave you yesterday, it had a plus and a minus, but that was so we could kind of understand what was happening on the with the rectangular coordinate plane. But you only have positive numbers here, right? So there is no -4 that you go to. Is that Daisy? I'll let her. There is no -4. So there is only a +4. That's why you either use the rule. Gosh. You either use the rule, and really just passing through the origin is the same rule. Plus, if I did that, and this was like a crazy angle, it's going to make it much more difficult for me to figure out where the angle is, and it's also going to lead to some other weird things moving forward. So it's just not, it's a bad habit that you don't want to start because you think it makes it easier. Make sense? All right. So with all that said, now you can graph what I'm going to do. Let's look at this theta equals pi fourths. All right, so that means that if the radius is 4, my angle is pi fourths. If the radius is 6, my angle is pi fourths. If the radius is 0, I'm at pi fourths. If the radius is -4, I'm at pi fourths. What is this going to graph? A line, exactly. It's going to be a line that goes, oh, that was totally the wrong point I just did, isn't it? Sorry about that. Hit the wrong thing. There we go. It's a line. Now it looks more like a line. You have this line right here that goes through pi fourths. Good with that? So you graph this one. Your line looks something like that. What questions do you have? Okay, so now we're going to look at one where we have r and theta in there. And to get this one going, we are going to go ahead and fill out a little table of values. So our ordered pair is r theta, but theta is the independent value. Our radius is dependent on what theta is. So the independent and dependent variables are flipped around here, where we're used to the first one being the independent. So I substitute in theta. So 2 times the cosine of 0. What's the cosine of 0? 1. I multiply that by 2, and I get 2. What is the cosine of pi 6? Square root of 3 over 2. I multiply that by 2, and I get square root of 3. What's the cosine of pi thirds? 1/2. Multiply that by 2, I get 1. What's the cosine of pi halves? 0. So it's 0. What's the cosine of 2 pi thirds? -1/2, right? Because it would be the same as this, but negative. So when I multiply by 2, I get a -1. So 5 pi 6 should be the same as this one, but since this is in the second quadrant, it will be negative. What is the cosine of pi? -1. Multiply it by 2, I get -2. These two will be the same. This is in the third quadrant, so it's negative. These two will be the same, but negative. 0. Now we're in the fourth quadrant, right? Which means this will be positive and this will be positive. Okay, we're good with that? Okay, so now let's plot these things. In order to do that, we need to know that the square root of 3 is about 1.8. Okay, just so that we have something we can, here I am graphing. Okay, so when theta is 0, the radius is 2. When theta is pi 6, the radius is about 1.8, which is about right there. When theta is pi thirds, my radius is 1. When theta is pi halves, my radius is 0. When theta is 2 pi thirds, my radius is negative 1. So I'm right there. Then when theta is 5 pi 6, my radius is negative 1.8-ish. Right there. Then when theta is pi, my radius is negative 2. I already have a point there because I've already gone around I've only gone around the unit circle halfway, but I've made my way all the way around the circle because remember, if you want to get all of the cosine values, you only go from 0 to pi. That's pretty much what we did. So we're good. So what is this thing going to graph? Okay, let me back up. Pause. We're in the polar coordinate system. Everything is curvy. Okay, so we're not going to have anything pointy like absolute value or anything like that because everything's either a straight line or everything is curvy. So this is not going to be a hexagon. Throw that out there because I know that's what we were thinking. It's okay, but that's why I need to make my little disclaimer. I know you don't know what you're getting into, so that's okay. So given all what I just said, now what do you think it's going to graph? It's just a circle. We're not going the crazy step. Remember, these are the boring ones. They're not exciting. We'll get to the exciting ones, I promise. Okay. So it's just a circle. Okay. And I know mine doesn't really look like, it looks a little lopsided, but we can plot more points and make it look prettier. But then the points get yuckier and just kind of make a dotted line, make it look as much like a circle as you can. Now let's look at what we have compared to our equation. This 2 here, when you look at this circle, that is the diameter of this circle, right? And the circle is attached to the pole. So right now, we are graphing this kind of equation. We're not here yet, meaning I'm not adding or subtracting anything. Cosine's not squared. It's not 2 theta. It's just plain old this right here. If you have something that's just a cosine theta or a sine theta, it will be attached to the pole part. One side of the circle is on the pole. And on the unit circle, is the x value cosine or sine? Cosine. So notice now again, we don't have an x and a y axis here, but it's hard not to look at this and think about an x and y axis because that's what we've been looking at our whole lives, right? So you can think about this being on the positive x axis. See how it's like laying there? So if that was a negative 2 cosine theta, it would still be attached, but it would be over here on that side. Basically, it would be reflected over there. Does that make sense? And it would be on the negative x-axis. Okay? And we're going to look at some more of those. I just want you to kind of see what's happening. We're not going to have to fill in this chart for everything that we do. Okay? This was just so that we could kind of explore what was happening. And, if we want big, beautiful, pretty, perfect graphs, we're going to use graphing software. If we need an idea of what's happening with the function, then we should be able to sketch it by hand. Okay? So let's look at the next one. So now I have r sine theta. So remember that the a value, this right here is my diameter. So my diameter is 1. Let's just plug in, and I also told you it is definitely attached to the pole. So what is the sine of 0? 0. So it's not laying here. What's the sine of pi halves? 1. And there's your diameter right there. So your sine value on the unit circle is your y value, right? So the sine is going to be on the pretend y-axis, basically. And if we can plot those 2 points, and then you just kind of make it into a circle, you're good to go. Okay? That's all you need to understand. Because that's the most important thing for you to get out of this without it being a perfect graph or something, is which axis is it on, or which way is it facing. Right now you can think of it as the x and y axis as we're kind of transitioning into it. Which way is it facing and what the diameter is, those are the important parts right there. Okay. All right, so now I have r equals negative 2 sine theta. So again, we know that it's on the pole. And then the sine of pi halves is 1. I multiply that by a negative 2. That means my radius is negative 2. So I come down here. So since that's negative 2 sine theta, that's why it's on the pretend negative y-axis. And then that's good enough to just make it into a circle. We good on those? All right, so let's look at number 8, and then we'll write some stuff off to the side here. I have -3 cosine theta. So I know it's attached. It's cosine, so it should be centered on that x-axis that we think about. And it's -3, so it's going to be over here. And this is what it will look like. Any questions about those? All right, so I've been saying like pretend x-axis, pretend y-axis. Your pretend x-axis is really when theta is 0, right? Your pretend y-axis is really when theta is pi halves. Okay, so those are how we kind of want to think about them. So let's write some things down here. All right, so if I have r equals a cosine theta, a being that leading coefficient there, this is going to be a circle with center on theta equals 0. So the center of this circle is right here. It's on theta equals 0. That's why it's like centered on it. Okay. And A is equal to the diameter. When I have r equals sine theta, then I have a circle. I can't spell circle. Circle with center on theta equals pi halves. So see, here's my center. It's on theta equals pi halves. Ooh, that circle was really lopsided. I can tell once I put the center on there. And then once again, A is the diameter. All right. What questions do you have? Anything at this point? Okay, so then I have r equals cosecant theta. What is cosecant the reciprocal of? Sine. So I can have r equals 1 over sine theta. Okay, so let's plot some points and think about what's happening here. So let's substitute in 0. What's the sine of 0? 0, and then 1 over 0 is undefined, right? So can't do anything with that. What's the sine of pi sixths? 1/2. I take the reciprocal and I get 2. So at pi sixths, I'm at 2. What's the sine of pi thirds? Square root of 3 over 2. That's yucky, so let's see if we can do it without it. If not, we'll come back and do it. What's the sine of pi halves? 1, and the reciprocal of 1 is 1. Okay? Then 2 pi thirds, that's yucky, right? We'll skip that. We'll move on to 5 pi 6, which is 1/2, and the reciprocal of that is 2. Okay? So what does this look like it's going to graph? A line. So here we get a horizontal line, like so. So if you have A equals cosecant theta, where your A here is 1, you have a horizontal line through the point A pi halves. A being that, so see I have my A is 1. 1 pi halves is right here, so through that point I have a horizontal line. Okay? Make sense? Questions about that? All right. So then let's try 10. What's the reciprocal of secant? Oh, goodness, cosine. So r equals 1/2 times 1 over cosine theta. All right, so what's the cosine of 0? 1 times 1/2 is 1/2. What's the cosine of pi 6? Square root 3/2. That's yucky. Let's skip it. What's the cosine of pi thirds? 1/2. Reciprocal is 2 times 1 is, I'm sorry. You're right. Good. That was right. Not what I meant to say, but I was like 2. No, yeah. Times 1, it is 2. I'm supposed to multiply by 1/2, so what's 2 times 1/2? 1. There you go. It's like, what are they thinking? Okay. Question I asked them. All right. So then, got that there. All right. What is the sign of pi halves? I'm sorry. Oh my God. Yeah. You're giving me the right. I'm sorry. I'm not trying to confuse you. I don't know what my brain is doing right now. The cosine of pi halves is 0. The reciprocal of 0 is undefined, and I don't have anything to graph. All right. Cosine of 2 pi thirds. Negative 1/2, right? Reciprocal is 2. Times 1/2 is a negative 1. So at 2 pi thirds, my radius is negative 1. And so I have this point right here. And so once again, I get a what? A line. And this time it is a vertical line. So this is a vertical line. Through A, comma, 0. And your A is 1/2 in this case. And your cosine is your x value on the unit circle, right? And your vertical lines are your x equals lines, so these kind of jive with what we already knew anyway. Okay, are we good on that? All right, so I want to show you a couple of things on Delta Math just to make sure that there's no confusion when you do this. Okay, so we're going to graph this polar curve, r equals negative 2 sine theta. So you have to choose which curve that you are going to graph. We have only talked about circles and lines, so don't choose the other ones. The only reason I'm mentioning this is because these two right here look very similar to each other, don't they? And without you having any other knowledge, I can totally understand why you wouldn't even know that there's any difference there. This one, however, I mean, if you look really closely, the bottom is kind of flat. All right, so it's not really a circle. So just when you do this and you're trying to do circles, make sure you actually choose the circle, okay? And then this is negative 2 sine theta. So we'll think about it, it's like, is it going to be like a vertical circle or a horizontal circle? It's sine. Vertical, okay? Which, I mean, a circle's a circle, I know, but, okay. And it's negative 2, so 2 is my diameter. So it's easiest also if you change your diameter before you move it. Trust me, it makes it a little bit easier. So I need my diameter to be 2. Oh, wait, my diameter is already 2, right? Make sure you're not thinking right. Oh, my gosh. I didn't realize it would take away my circle. There we go. So my diameter is 2. Kind of got lucky, right? So then I just need to move it. It's vertical. So it's going to go right here because it's negative. Yeah? Oh. Okay, we'll see if it takes it. I think it should. If I get it wrong, then you'll know you have to be. They're usually a little forgiving. Yeah, that's good enough. And then it shows you, so you have this little slider thing here. Now, this is not showing you the same graph in rectangular and in polar because this is not how you would convert the equations. But it's showing you the difference of negative 2 sine theta graphed in polar or graphed in rectangular. And you can slide this, and it graphs it. So you can see that this is graphing your sine function, and over there it actually just graphs a circle. But this is starting your sine function to look like that. Okay? And then the other one I wanted you to see was, so this one, theta equals 5 pi 4, so you choose the line. These aren't marked, so you have to figure out where they go. It's not that big of a deal. 5 pi 4 is in which quadrant? Third. So I'm going to rotate this around to that third quadrant there. And then I get my line. And it shows me these same things graphed in two different functions. Okay? We good? What questions you got? Alrighty. So go ahead and get your notes taped in and get started on this Delta Math. You have a good bit of time left to get some things going.